Let us look at addition of two sparse matrices in coordinate list representation. Suppose I have sparse matrices like A, B, and I want to add these two and get the result in C. So this is in mathematical form. But when it is represented in a program in the form of a coordinate list or three column method, whatever it is, for that how we perform the operations like addition operation we will see. So first of all, I will solve it manually, that is using pen and paper. Think that using pen and paper, how I can add these two and what should be the result. So let us do it. The dimension of first matrix is 5 by 6. Second matrix is also 5 by 6. So yes, they can be added. So for adding two matrices, their dimensions must be same. Then the third matrix I have already taken here the size 5 by 6. Now what are non-zero elements in first matrix? 6, 7, 2, 5 and 4. And the non-zero elements are 3, 5, 2, 7, 9, 8. Now a normal procedure for adding two matrices, we will run the same method. That is, every element of A is added with the corresponding element of B matrix. So let us add them. So let us start with first one. First element is 1 comma 1. 1 comma 1 here. 0. 0 plus 0 is 0. Then 1 comma 2 with 1 comma 2. This is also 0. So I will do the rest. This is 0 and 0. So this is 0. This is 6 and here it is 0. So 6 plus 0 is 0. Then remaining 2 are 0, remaining 2 are 0, 0. Now second row here we have non-zero elements. First is 0 and next is non-zero. And here we have 0 and non-zero. So this is 0 and this corresponding elements, they are at same index I and j. So 7 plus 3, this becomes 10. And the next element is 0, 0 and here we have one more non-zero for which there is 0 here. So it will be just 5. So 0, 0, 5, 0. Then third row 2, 5 and here there is 2 here. So this is 0, 0, 2 plus 0, 2 only, 0 plus 2, 2 only, 5 plus 0, 5 only, then 0, then 7. So if I take them, first one is 0, then 2 as it is, 2 as it is, 5, then 0, then 7. Then fourth row, all are zeros here. So 0 added with these will get the same thing. So we will get the same row. 0, 0, 0, 9, 0, 0. And the last row, 4 and then here 8. So this is 12. And the rest of all zeros, here also rest of all zeros. So these are all zeros. So this is what the addition of two sparse matrices A and B, and I got the result C. So C is obtained by adding A plus B. How many non-zero elements I got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 non-zero elements I have. Now let us do the same thing using coordinate list representation. Let us represent this as a coordinate list. So in this sparse matrix, let us count the number of non-zero elements. 1, 2, 3, 4, 5. 5 non-zero elements are there. So I will take a horizontal table of size 6. Let us call this as A. So it may be a two-dimensional array or array of terms. How to implement it in programming, we will discuss afterwards. So at 0th index, I will write down the dimensions, that is 5 rows and 6 columns, 5 rows and 6 columns, and the number of elements 1, 2, 3, 4, 5 non-zero elements. Now let me fill this table with the non-zero elements. So first row, there is element 6 at column 4. First row, fourth column, value 6. Second row, second column, 7. Second row, second column, 7. Third row, fourth column, 5. Third row, fourth column, 5. Fourth row, there is nothing. Third row, second column, 2. Third row, second column, 2. Then third row, fourth column, 5. Third row, fourth column, 5. Then fourth row, there is nothing. Fifth row, first column, 4. Fifth row, first column, 4. This is how it is represented. Now second one, I will do it quickly. So I have a representation for B matrix also, which is having 5 by 6 dimension and 6 non-zero elements, and all those elements are here. Let us see how addition can be done. We have to add these two matrices from this representation. So we need one more array of coordinates, that is the same type of array for C, but we don't know how many elements it may be getting. So what should be the size? See how many elements here? 5. How many elements here? 6. Total 11. If none of them is matching and none of them is added, then at most 11 elements are required. So I should have space for 11. But I will not take 11. We know very well. Answer we know. So how many non-zero elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the size. So I will take the size 9. Then I will add it from here. I have a array ready here. Now let us start adding them. The dimension are 5 and 6. I don't know how many elements I may be getting. Once I get the number of elements, I will update this one. So let us start adding. So for adding, I will go on the first term of this one and let us say I, and this first term of this one, let us say j. See, this 0th index is having the dimension and number of elements. Now let us start how to add them. First check the row number here and row number here. That row number is smaller. So that element comes before this element. They are not in the same row. So that first row 1 element comes here. So we'll include that element here. Directly it is included. So you can see that here we wrote directly 6. 6 directly came from here. So same thing, it's not added with anything. Then as we have copied this element, move to next element. Compare rows. Rows are same. Compare columns. Columns are also same. So these are matching. So add 7 plus 3. So row number is 2, column number is 2, and add them. And move I also and move j also. So this is what we got 10 here, because the 7 and 3 were matching. Now next element, row number 3, row number 2, this element come first. There is no matching of rows, so directly take this element, smaller row number, copy it here. Then move to next. Now row number 3, they are matching. Column 2, column 3. So this element come first. So they are not matching, but this element come first. So take this 3, 2, 2. So 3, 2, 2. See, this was the element. This was the element. Then move to the next element, I. We are here. 3, 3. Row numbers are matching again. Now check the column number. Column number here is 4 and here is 3. So this element come first. So 3, 3, 2. This is the second element in that row. Then move j to next element. Now compare. Row number 3, row number 3. So same row number, but column number, this element come first. So 3, 4, 5. So 3, 4, 5. 3, 4, 5. This one. Then as we have copied this one, move to the next element. Row number 5, row number 3. So this element smaller. So this will come as it is. So 3, 6, 7. Then move next. Row 5, row 4. So this is smaller. 4, 4, 9. Then move next. Row matching, column also matching. Oh, they are in the same place. So add these two elements. So this is 5, 1 and 4 plus 8, 12. So this is how we can add by scanning through array A and scanning through array B. And if the rows are matching, check for the column. If that is also matching, then add them. If row is small, directly copy it. If column is small, directly copy it. So that's all about sparse matrix, and the operation like addition I have shown you. So similarly you can do subtraction. So how it can be done through a program, I will show you that.